While construction sites across the Western world rely on heavy steel frameworks and industrial cranes, something extraordinary is happening in the skylines of Hong Kong, Macau, and parts of mainland China. Rising hundreds of feet into the air, wrapped around gleaming glass towers and concrete monoliths, you'll find something that seems impossibly fragile. Bamboo, not steel beams, not aluminum frames. Bamboo. The same grass-like plant that pandas munch on for breakfast is somehow holding up workers, materials, and entire construction operations on some of the world's tallest buildings. This isn't some quaint tradition clinging to life in rural villages. This is cutting-edge construction in one of the most expensive real estate markets on the planet. And the question that stumps engineers, architects, and safety inspectors from around the world is simple. How is this even possible? And more importantly, why would anyone choose bamboo over modern steel scaffolding when building a skyscraper? The answer reveals an ancient engineering marvel that's been hiding in plain sight for over 1,000 years. The unexpected strength of bamboo. Let's address the elephant in the room. When most people think of bamboo, they think fragile. They think decorative. They certainly don't think structural integrity at 40 stories high. But here's where the numbers get interesting. Bamboo has a tensile strength of 28,000 pounds per square inch. To put that in perspective, steel has a tensile strength of around 23,000 pounds per square inch. Read that again. Bamboo is actually stronger than steel in tension. This isn't marketing hype or exaggeration. This is materials engineering fact. Pound for pound, bamboo outperforms steel in its ability to resist pulling forces, but strength alone doesn't tell the whole story. Bamboo scaffolding typically uses a specific species called cao jue, or tall bamboo, which grows primarily in the Guangdong province. These poles can reach 40 to 60 feet in length and have been growing for at least 3 years before harvest, ensuring maximum strength and minimal moisture content. The older the bamboo, the stronger and more reliable it becomes. The engineering principle at work here is fascinatingly simple. Bamboo's hollow cylindrical structure creates what engineers call an optimal strength-to-weight ratio. The plant naturally grows with nodes, those ring-like segments you see along the stalk, which act as internal reinforcements. Nature essentially designed bamboo as a pre-engineered structural tube. Each section is a self-contained unit that distributes load efficiently while remaining incredibly lightweight. A single bamboo pole weighs a fraction of its steel equivalent, yet can support hundreds of pounds. On a typical Hong Kong construction site, bamboo scaffolding can safely hold up to 4,000 pounds per square meter. That's more than enough to support workers, tools, and building materials simultaneously. The human element. But strength statistics don't explain why construction companies continue to use bamboo when steel alternatives are readily available. To understand that, you need to meet the bamboo scaffolders themselves. These aren't your typical construction workers. They're practitioners of a highly specialized trade that requires years of apprenticeship and incredible skill. In Hong Kong alone, there are fewer than 3,000 certified bamboo scaffolders remaining. Most are over 40 years old, having spent decades mastering their craft. These workers can erect a 30-story bamboo scaffold faster than a steel crew can assemble a comparable metal framework. We're not talking slightly faster. We're talking about completing in days what might take weeks with conventional scaffolding. The technique involves no bolts, no welding, no power tools, just bamboo poles and nylon straps. The traditional method used natural fiber ropes, but modern scaffolders have adopted synthetic materials that provide better grip and longer durability. Each connection point, called a knot or hitch, is tied by hand using techniques passed down through generations. A master scaffolder can tie these knots in seconds, creating joints that are both incredibly strong and slightly flexible. This flexibility is crucial. While steel scaffolding is rigid, bamboo scaffolding has a small degree of give. During typhoons, which regularly batter Hong Kong with winds exceeding 100 miles per hour, this flexibility allows the entire structure to sway and absorb force rather than resist it. Steel scaffolding might seem sturdier, but that rigidity becomes a liability in extreme weather. Bamboo bends, steel breaks. The economics that defy logic. Now let's talk money. because this is where bamboo scaffolding becomes truly remarkable from a mega project perspective. Steel scaffolding is expensive, not just the material itself, but the entire operation. Steel requires heavy machinery to lift in position. It needs specialized tools for assembly. Transport costs are significant because of the weight. And at the end of a project, that steel needs to be carefully disassembled, transported, stored, and maintained. Bamboo operates on an entirely different economic model. A bamboo pole costs roughly 1/7 the price of an equivalent steel tube. Transportation is simpler because bamboo is lighter. A single worker can carry several poles at once. No cranes required for positioning, no specialized tools needed. The nylon straps cost pennies compared to industrial fasteners and bolts. But here's the real economic kicker. Bamboo scaffolding is disposable. After a construction project, the bamboo has often deteriorated from weather exposure and can be discarded or recycled. Steel scaffolding requires significant investment in storage facilities and maintenance. You need warehouses, you need staff to manage inventory, you need regular inspections for rust and structural damage. Bamboo eliminates all those ongoing costs. For a developer managing multiple projects simultaneously across a city like Hong Kong, where space is at an astronomical premium, the ability to simply discard scaffolding materials after use rather than storing them is an enormous operational advantage. You're not paying rent on storage facilities. You're not paying workers to maintain and track inventory. You're not dealing with depreciation and replacement schedules. And there's another economic factor that often gets overlooked: speed. In high-value real estate markets, time is literally money. Every day a building sits under construction is a day it's not generating rental income or sales revenue. Bamboo scaffolding goes up in a fraction of the time required for steel, which means construction can begin sooner. At project completion, bamboo comes down just as quickly, which means buildings can open for business sooner. The environmental angle. In an era where sustainable construction is becoming increasingly important, bamboo presents an environmental profile that steel simply cannot match. Bamboo is one of the fastest growing plants on Earth. Some species can grow up to 3 feet in a single day. The cowjoy bamboo used in scaffolding reaches harvest maturity in just 3 years, compared to the decades required for traditional timber. When bamboo is harvested, the root system remains intact and immediately begins producing new shoots. There's no need for replanting. The same bamboo grove can be harvested repeatedly every few years indefinitely. This regenerative quality makes bamboo functionally renewable in a way that most construction materials simply aren't. The carbon footprint comparison is stark. Steel production requires mining iron ore, smelting at incredibly high temperatures, alloying with other metals, and extensive industrial processing. The steel industry accounts for approximately 7% of global carbon emissions. Bamboo, on the other hand, is essentially carbon neutral. As it grows, bamboo absorbs carbon dioxide. When it's eventually disposed of after use, that carbon is released, but no additional emissions were generated in its production beyond harvesting and transportation. For construction companies facing increasing pressure to demonstrate environmental responsibility, bamboo scaffolding offers tangible sustainability credentials. It's not greenwashing. It's genuinely low-impact construction infrastructure. The safety paradox. Here's where the story gets controversial. Western safety inspectors often look at bamboo scaffolding with horror. It seems inherently dangerous. Workers climbing 40 stories on what appears to be a fragile lattice of wooden poles, tied together with rope. Surely this must result in catastrophic accident rates. The data tells a different story. Hong Kong's Labor Department closely monitors construction safety, and bamboo scaffolding doesn't show significantly higher accident rates than steel alternatives when properly installed by certified professionals. The key phrase there is properly installed by certified professionals. Bamboo scaffolding accidents, when they occur, are almost always the result of improper installation, use of degraded materials, or work by uncertified contractors trying to cut costs. When built to code by trained scaffolders, bamboo scaffolding is remarkably safe. The Occupational Safety and Health Council in Hong Kong has stringent regulations governing bamboo scaffolding, including load limits, inspection requirements, and weather-related restrictions. The slight flexibility that makes bamboo resilient in wind, also provides a tactile feedback system for workers. They can feel when a structure is under stress. Steel scaffolding doesn't provide that sensory information. By the time steel begins to show visible signs of stress, it may be approaching catastrophic failure. There's also a human factor. Bamboo scaffolders take enormous pride in their work. Their reputation depends on safety and reliability. These craftsmen have a vested interest in building structures that won't fail. It's not just about regulations. It's about professional honor and the knowledge that their colleagues will be working on the structures they build. The future of an ancient craft. But despite all these advantages, bamboo scaffolding faces an uncertain future. The trade is dying. Younger generations aren't learning these skills. The physical demands are intense. The pay, while decent, doesn't match other construction specialties. Most importantly, mainland China has been phasing out bamboo scaffolding in major cities, mandating steel alternatives in accordance with international construction standards. Hong Kong remains one of the last major urban centers where bamboo scaffolding dominates the skyline. Even there, the number of certified scaffolders is declining. Training programs exist, but attracting apprentices is increasingly difficult. Within a generation, this 1,000-year-old engineering practice might effectively disappear from modern construction. Some architects and engineers are now advocating for a middle ground, hybrid systems that combine the advantages of both materials. Steel for the primary load-bearing structure, bamboo for access platforms and decorative facades. Research institutions are studying whether bamboo scaffolding techniques could be adapted for use in other countries, particularly in developing regions where steel remains prohibitively expensive. There's also growing interest in bamboo as a permanent building material, not just temporary scaffolding. Engineered bamboo products, where bamboo fibers are processed and compressed into structural beams and panels, are gaining traction in sustainable architecture. The principles that make bamboo excellent for scaffolding, its strength-to-weight ratio, flexibility and renewability, translate well to permanent structures. The next time you see images of construction sites in Hong Kong or Macau, look closely at those seemingly impossible webs of poles wrapping around buildings. You're witnessing an engineering tradition that has quietly outperformed modern alternatives for over a millennium. If you found this deep dive into unconventional engineering fascinating, make sure you're subscribed to the channel. We explore the world's most impressive mega projects, from ancient innovations that still work today to cutting-edge construction pushing the boundaries of what's possible. Thanks for watching, and I'll see you in the next one.